A complex ethical dilemma is explored in this video, concerning the programming choices made when autonomous vehicles face unavoidable accident scenarios. The moral tightrope walked by engineers designing these systems is carefully considered, highlighting the societal implications of their decisions. Imagine this: your self-driving car is moments away from an unavoidable crash. Does it swerve to save your life, potentially endangering a school bus, or does it prioritize the most lives, even if it means sacrificing you? This isn't a hypothetical movie plot, it's the real ethical tightrope engineers are walking right now as they program autonomous vehicles. Picture yourself on a quiet street, enjoying the ride in your autonomous car. Suddenly, a child darts into the road, and an oncoming truck is seconds away. What does the car do? The choices programmed into these vehicles aren't just lines of code, they're moral decisions with profound societal implications that could change our world forever. Autonomous cars are designed to be safer, but what happens when a crash is truly unavoidable? Who lives and who dies, and who decides? This video dives deep into the unsettling paradox of programming morality into machines, revealing the ethical dilemmas that will shape the future of transportation and impact every single one of us. In the car-based trolley problem, there is no single agreed-upon correct answer. Instead, the choice of whether to sacrifice the occupants or external individuals, like pedestrians, depends on the chosen ethical framework, such as utilitarianism, saving the most lives, or deontology, avoiding direct harm. The problem explores the complexities of programming self-driving cars to make such impossible choices, highlighting the difficulty in balancing outcomes versus actions and raising questions about whose lives are valued. The theoretical nature of the trolley problem is complicated by real-world factors like the inability to know exact outcomes, the presence of non-human obstacles, or variations in road conditions, making a simple swerve or not choice more complex. This philosophy suggests the best action is the one that produces the greatest good for the greatest number. While AI aims for precision, it faces limitations such as biased data, lack of common sense, and complex, unpredictable behaviors, leading to potential real-world failures like the fatal Uber self-driving incident. Current AI applications, from autonomous vehicles to medical diagnostics, involve programming and deployment in real-world scenarios, but achieving true, error-free chilling precision is complicated by the inherent nature of AI as an imperfect model of reality. Developers and policymakers are working to mitigate these risks through robust data infrastructure, cybersecurity, ethical considerations, and legal frameworks. AI helps in analyzing medical images to detect diseases, yet it's not foolproof and still carries a margin of error, requiring human oversight. Inaccurate or biased training data can lead AI systems to amplify existing societal inequalities and errors, rather than eliminating them. There isn't a universally agreed-upon moral algorithm for a number of reasons. Human morality is complex and diverse, with varying ethical frameworks and values. Ethical decision-making in situations like self-driving car accidents is highly contextual and often involves human judgment, as shown by the trolley problem, and applying these principles to AI is an active area of research, as seen in the work on AI safety and alignment. Companies and individuals often have different values and expectations, leading to clashes in how they operate and what they deem acceptable or desirable. In summary, while the idea of a universally agreed-upon moral algorithm is appealing, it's an impractical ideal given the multifaceted nature of human morality. Instead, we see ongoing efforts to understand, codify, and implement ethical principles in both human and artificial systems, acknowledging that there is no single, simple solution that satisfies everyone. Passenger trust requires clear communication and predictable, comfortable behavior from the AV, while pedestrian safety relies on the AV actively detecting and avoiding conflicts through advanced sensors and software, with a strong emphasis on prioritizing safety in its algorithms. Building both trust requires reliable technology, well-designed human-machine interfaces, HMIs, for pedestrians, and a demonstrated commitment to safety, but often, these goals present a difficult balance, as overly cautious AVs might impede traffic or create new hazards, while overly aggressive ones could erode trust and pose risks. Pedestrians can be hidden from view, and their movements can be unpredictable, creating scenarios where even perfect sensing is insufficient to guarantee safety. Many studies on trust and safety are conducted in simulated or virtual reality environments, and validating the performance and behavior of AVs in real-world conditions is crucial. Regulations diverge because of different national values, public policy goals, and approaches to governance, leading to varying legal systems, enforcement mechanisms, and standards for issues like data privacy, product safety, and environmental policy. While divergence can stem from legitimate domestic needs and goals, it often increases costs for international businesses and requires them to navigate complex, inconsistent rules across jurisdictions. Policymakers can address this by promoting international regulatory cooperation, aligning with international standards, and developing cross-border recognition frameworks to reduce avoidable trade costs. The push for international standards is driven by the need for harmonization, efficiency, and security in global trade, while the push for local customs is rooted in preserving cultural identity, supporting local businesses, and adapting to specific national regulations and needs. Efforts are being made to encourage the adoption of data standards and digital tools to move beyond paper-based trade, which can significantly hinder efficiency and cause uncertainty for businesses, especially small ones. While global standardization is beneficial, there is also a need for operational flexibility to allow for local customs and conditions, ensuring that standards are not overly burdensome or irrelevant to local contexts. Current legislative discussions for autonomous vehicles (AVs) globally are characterized by a lag between rapid technological advancement and regulatory development, with a general focus on testing phases rather than full-scale deployment. The United States has limited federal guidance, leaving state-level legislation to dominate, often creating a fragmented legal landscape. India, like many nations, currently lacks a comprehensive legal framework for AVs but is seeing increasing investment and market growth for the technology. Your role in a driverless future shifts from active driver to passenger, focusing on managing technology and building trust in AI systems, while the new system will reduce accidents, improve mobility for all, and reshape urban landscapes. However, this requires careful consideration of job displacement, data privacy, increased potential for sprawl or congestion depending on ownership models, and the need for updated infrastructure and regulations to ensure safe and equitable adoption. While AI-driven systems can improve fuel efficiency, the increased energy demands of autonomous vehicles and potential for greater sprawl could pose environmental challenges. The move to autonomous vehicles will require societal adjustments to build trust, address equity issues, and navigate complex questions of responsibility in the case of incidents. Driverless vehicles promise to drastically reduce accidents caused by human error, potentially eliminating 90% of them. Your opinion matters in public debate because it influences policy, holds government accountable, and strengthens democracy by reflecting diverse perspectives and ensuring decision-makers are informed about the needs and desires of the people. Participating in public discourse through various forms, from voting to expressing views on specific issues, empowers citizens to shape society and is a fundamental aspect of democratic participation. When you share your informed views, you provide valuable input that helps policymakers understand the potential impacts of their decisions on the lives of ordinary people. Vote, contact your elected officials, sign petitions, and support causes you believe in to influence decisions. Stay aware of current events and issues so you can form and express well-informed opinions. When you share your informed views, you provide valuable input that helps policymakers understand the potential impacts of their decisions on the lives of ordinary people. To foster better autonomous vehicles (AVs), it's crucial to engage policymakers and tech developers through collaborative platforms and policy frameworks that promote safety, equity, and public trust, as well as address the unique challenges of diverse populations and infrastructure. This involves dialogue between stakeholders like tech companies, regulators, and citizens to align objectives, create clear guidelines, foster public understanding, and ensure AV systems are inclusive and reliable for widespread adoption. Establish frameworks that encourage dialogue between tech developers and policymakers to create shared objectives for AV development. This ensures regulations align with real-world challenges and promotes responsible innovation. Plan for the integration of AVs with existing and new infrastructure, such as smart roads and dedicated zones for low-speed AVs, to ensure compatibility with pedestrians, cyclists, and other road users. Recognize that AV technology and business models are rapidly evolving. Policymakers should adopt an adaptive approach to regulation, staying informed about the latest innovations and proactively shaping AV evolution to align with societal goals. Engage citizens through public forums and dialogues to educate them about AV capabilities, limitations, and safety measures. This helps build trust, manage public perception, and gather insights into consumer needs. Involve all relevant stakeholders, automakers, fleet operators, network providers, users, and the public, to understand how changes in one area can impact others and to gain a comprehensive view of AV deployment challenges.